Bismillahirrahmanirrahim. Dear students of class first year, Assalamu alaikum. Students, today we are going to start unit number 2, and the name of that unit is atomic structure. The topic is, this is the first topic, and this is about the brief history of atomic models. Students, you know that different types of atomic models were presented at different times. We will have to briefly discuss a few atomic models which are in the history. Number 1, Plum pudding model. It was first proposed by J.J. Thomson in 1904. It looks like this one, where there are yellow negatively charged particles that were called electrons, and the red color shows the positively charged matter. So the electrons are randomly distributed in a positive sphere. This is similar to the plum pudding. These are electrons, and this is the positive matter or the positive sphere. Electrons are randomly spread in a sphere of positive charge. When heated, the electrons vibrate to produce electromagnetic field. Students, it says that when we heat an atom, the electrons vibrate with the higher velocity, and thus they produce electromagnetic field. Number 2, Rutherford atomic model. It was proposed by Ernest Rutherford in 1911. It looks like this one, where there is a positive center which is called nucleus, and according to this model, the whole mass of atom is located at this very small center that is called the nucleus, and the electrons are revolving around the nucleus in orbits. These are shown in red color, and the electrons are shown in yellow color. If we label the diagram, then the black will be the nucleus, then these are the orbits, and these are the electrons which are revolving around the nucleus. According to Rutherford atomic model, the electrons are revolving around the nucleus. Whole mass is located at nucleus. Most of the space inside the atom is empty. Almost 99.9% space is empty, while the whole mass of atom is located at a very small dense nucleus. Drawbacks of Rutherford model. There were a few drawbacks of Rutherford model. For example, it couldn't explain the stability of atoms. You know that atoms are stable, but according to this model, since electrons are revolving around the nucleus, they should release energy, they should emit energy, and by decreasing the amount of energy in them, they should fall into the nucleus. So the atom must be unstable. While the atoms are stable, this stability cannot be explained by Rutherford atomic model. Number 2, it could not explain the line spectrum of atoms. According to this model, the electrons are continuously revolving around the nucleus, so the spectrum should be continuous, but in fact the line spectrum is obtained whenever we see the spectrum of atoms. That is why it cannot explain the line spectrum of the atoms. Number 3 is Bohr atomic model, and this is the modern one. Although there are a few models which are more modern than this one, but it is successful in explaining different behaviors and different properties of the atoms. It was first proposed by Niels Bohr in 1913. It looks like this one, where There is a nucleus at the center of the atom. Then there are orbits which are circular in shape, and they are at a specific distance from the nucleus. These are called energy levels, or these are also called the orbits. And the electrons are revolving around the nucleus in these fixed circular orbits. The main points of this Bohr model are: electrons are revolving around the nucleus in fixed orbits or fixed shells. Energy of the electrons is fixed or constant as long as the electron remains on its own shell. Its energy neither increases nor decreases. Electrons jump from lower to upper orbits when they absorb energy. According to this model, when energy is given to an electron, it transfers or it jumps from lower orbit of low energy towards the upper orbit of higher energy. Similarly, when it loses energy, it comes from upper to lower orbit. Energy required is equal to the difference between the two orbits. Students, the amount of energy that is required to jump an electron from lower to upper orbit is equal to the difference between the energies of these two orbits. For example, if lower orbit have 20 kilojoule energy and the upper orbit have 80 kilojoules energy, then the difference between 80 and 20 is equal to 60 kilojoules. Therefore, this electron will need 60 kilojoule of energy to jump from lower orbit towards upper orbit. The advantages of Bohr atomic model: it could explain the stability of atoms. You know, Rutherford could not explain the stability of atoms, while Bohr could explain the stability of atoms, because according to this model, electrons remain on its own shell, on its own orbit, as long as it neither emits energy or absorbs energy. So the atom will be stable and the electrons will not collide with the nucleus, or it will not be falling into the nucleus while revolving around it. Gave the idea of quantized energy levels. According to this model, since the orbits have fixed energies, therefore these are quantized due to their fixed energy. It could calculate the radius of hydrogen atom. This Bohr model was successful in calculating the radius of hydrogen atom as well as monoelectronic systems. Monoelectronic means those species which have only one electron. For example, hydrogen atom have one electron, helium plus one ion have one electron, and lithium plus two ion also have one electron. So it could calculate the radius of these species. It could explain the line spectrum of the atom. As you know that the atom makes a line spectrum that was not explained by Rutherford. So the Bohr model is able to explain the spectrum of the atom. The line spectrum of atom looks like this one, where there are specific lines between two regions of the spectrum. Drawbacks of Bohr atomic model. There are a few drawbacks of Bohr model also. Number one, it couldn't explain Zeeman effect. Zeeman effect is the effect of magnetic field upon the electrons of an atom while we take its spectrum, or we make its spectrum. It could not explain Stark's effect. Stark effect is the effect of electric field upon the electrons. When electrons or atom is present in electric or magnetic field, then its spectrum is affected and it splits into fine spectrum where there are more lines as shown in the previous diagram. Why these lines appear, it was not explained by Bohr. It could not explain the fine spectrum of hydrogen, as I have told you that when we observe the spectrum of hydrogen through a powerful spectrometer, then we see smaller lines apart from larger and bigger lines. So these fine lines are this fine spectrum cannot be explained by Bohr model. It could not explain the elliptical shape of the orbits. The elliptical shape of orbits was presented by Sommerfeld, so it could not explain the Sommerfeld atomic model. It could not also explain the Heisenberg uncertainty principle. According to this uncertainty principle, we are unable to calculate the exact position and the exact momentum or the exact velocity of an electron at a time. So Bohr was unable to explain the Heisenberg uncertainty principle. Thank you for watching this video. If you like this video, then please share it, and if you have not subscribed my channel, please subscribe it also. Thank you very much.